Hey, it looks like this one's oriented rightly. Sorry, the first part of this is sideways. No clue how that happened. But this is the back page of 11.6. This is all about, well, halfway, about cones. Your lateral area of a cone is pi RL, pi times the radius times your slant height. And your surface area is pi r squared plus pi RL. Again, this is the same thing because pi r squared is the area of your base shape. So you're just doing lateral area plus the area of the base, which is the same thing we were doing on the other side of the paper. Which is part of what I like about all these formulas is as long as you understand prisms and cylinders have two bases, so you have to have that 2b, whereas cones and pyramids only have one base, so you just need one singular b. As long as you're focusing on that, you're gonna be fine. Cones are so easy. You can, if you remember from doing cylinders, we just plugged everything into the surface area formula because you don't technically need your lateral area. It makes it so much easier. And again, I typically write mine backwards. So this is my area of the base. This is technically my lateral area. You look at your problem. 7 is obviously the radius. Your slant height on this one is going to be what's on the outside of your ice cream cone or your dunce hat or whatever you want to call it. But again, just pay attention to that. Slant height should always be on the outside of your figure, never on the inside. So you plug that in. Radius was 7, slant height was 11.4, you get 404.64. That is calculator work, easy peasy. Number 8, we're gonna skip it, but I do want to point out the fact that 27 is a diameter. And like yesterday, we very rarely want a diameter. Divide that by 2, you get a radius of 13.5. So make sure you're paying attention to those tiny details and doing it correctly. We are going to do number 9. Number 9 gives us the height of the cone, and it gives us the slant height of the cone, but we're missing, that radius portion. I have no idea why I have a 21 on my paper. We're just going to erase that because that is completely unnecessary information. All right, much better. So we want that value. Well, that's a 90. Do you see the right triangle? Because I do. So, remember how I said Pythagorean theorem literally never goes away, and you were going to do Pythagorean theorem in circles and you all laughed at me, and I said we were going to put triangles in circles and you all laughed at me? Well, now we're putting triangles and pyramids and cones, and guess what? Y'all don't get to laugh at me anymore. So on this one, we're going to do x squared plus 25.2 squared equals 27.3 squared. If you solve it down, you get 10.5. So that 10.5 is our radius. And then from there, pi radius squared plus pi radius slant height. Make sure at this point, slant height is, oops, I just drew that right through my thing. Slant height is always on the outside. Plug it all in, you get 1,246.9 inches squared. Again, easy peasy. The hardest part of that is Pythagorean theorem. So, number 10 is a working backwards. If a cone has a surface area of 822.78 centimeters squared and a diameter of 18 centimeters, find the slant height. So, you're dealing with a cone. You're dealing with the surface area of said cone. So you come up here. Oh, hey, that's our formula. Nice and easy. You bring that formula down, but it tells you it has a diameter. There we go. Diameter of 18. Don't want the diameter. We want to divide that by 2 and get that our radius is 9. And plug that in. So pi, 9 squared, plus pi. And I just put a capital L there because people complain about my handwriting. So you can make it a loopy L for slant height if you want. Just don't get it confused with lateral area. You subtract your pi 9 squared from your total area. That gives you approximately 568.31 equals 9 pi L. What operation's going on in between the 9, the pi, and the L? Multiplication. The opposite of multiplication is division. So you divide by that 9 pi on both sides, and you get a slant height of 20.1. Number 11 is circled, which meant I definitely wanted to do that one. So find the surface area of the figure to the left. Oh, that's why. It's a composite figure. Remember those composite figures we did with area where you had to separate it into your basic shapes and then run your area formulas? Guess what? You've got two basic shapes. You have a cylinder, versus a cone. So your surface area for a cylinder was 2 pi times the radius times the height. And remember, this height, that 12, is your height between bases. We talked about that the other day. You can make that a capital H if you want or not. And that 34 is your diameter. I get really sick of dividing my diameters by 2, but hey, there we go. So our radius is 17. Key information. Plus pi r squared. Do you see how I have a note that there's only one base? We're gonna segue into that for a second. This is a figure where you've got a composite. You want the surface area of that composite, area of all of the surfaces. Well, do you see this space right here, which would technically be one of our bases of our cylinder? That's not a visible base. It's being ignored because we dropped a cone on top of it. So the only base that it's wanting you to focus on this problem is this one down here. That is the only base that is actually out in the open. The other one has been, like I said, covered by a cone. So that's why instead of having, typically on this we would have 2b, we only have one base. So going along with that train of thought, your cylinder, your surface area, is pi radius slant height. There we go. 20, that's the only piece of information you're given on this cone. 20 is your slant height. It's on the outside, nice and pretty. This one has no base for the same reason that this one only had one base. Oops. Because we dropped the dunce hat right on top of the cylinder. So that base of the dunce hat is not calculated in our surface area. It's not a surface anymore. It's, invisible. So you're not adding a base here, and you're only adding one base here. So these are the type of figures that trip us up just because we get so dead set on running our formulas that we don't actually think mathematically about the problem. So make sure if you've got a problem like this in your homework packet that you stop and think about it before you answer. Or if you've already done the homework and you got the answer wrong, maybe that's why. Just plug all that in. I mean, you get 2,189.69 as your answer for your cylinder, 1,068.14 for your cone. Tack them together, you get 3,257.83. Number 12, the roof on a shed is a square-based pyramid. If the base has a side length of 10 feet and the slant height of the roof is 9.4 feet, find the area of the roof. So you want the surface area of the roof, and it doesn't give you a picture. Bear with me here. We're going to try to draw a square pyramid. It's going to be, beautiful. You all know how my drawings are. We're going to put a point right there, and we're going to connect all of our dots. Hideous, but it works. So it tells you it's a square base. You've got all of these nice, pretty 90s down here. If the base has a side length of 10 and the slant height is 9.4, find the area of the roof. Oh, I'm not even on it. Sorry, guys. I labeled the wrong thing. Slant height. How can I draw my slant height into my really ugly figure? All right, slant height, remember, it goes tip down to your side. with a 90. That is beautiful, let me tell you. So that right there is that 9.4. Well, your surface area formula, 1/2 times the slant height times the perimeter of the base. If we go through and label things, slant height is 9.4. Perimeter of the base, 10 plus 10 plus 10 plus 10 equals 40. So your lateral area is 1/2, 9.4 times 40. You just want the roof. Again, this is one of those, your pyramid is on top of a shed. Oh, this is gonna get really super ugly, guys. Do. Yep, not pretty. Shed. Do. You've got a shed back here. It's an ugly looking shed. I'm sorry. This is what happens when you try to do math at 7 o'clock in the morning. It's just not a pretty thing. But this base, that square base that it told us that we needed, it's invisible. You can't find the area of something that's, you could find the area of it. You can't find the surface area of something that's not a surface. It's calculating the area of the outside, all of these triangles. So again, if you remember what I said on the first day of notes, surface area is the area of all the surfaces. If you really wanted to, if you were really feeling froggy, you could go through and find the area of every single one of these triangles and add them all up, and it's going to give you the same answer, which, by the way, that answer, because there's no base, is 188 feet squared. So I hope you all are staying healthy. I hope you all are staying safe. I miss all of you guys, by the way. Apparently my snarky sassiness is getting too much for my husband because he asked me if I needed to go back to school to be with you to get rid of some of my sass. So I miss you guys.